Okay, I want to start off with two review problems. Solve the inequality graph your solution. So we have -2 minus 4. Since the nose is pointed that way to the right, it's a greater than sign. Again, that's greater than -16. So I solved this just like I would an equation at the beginning. I just need to graph my solutions on a number line. So I have to add 4 and divide by -2. Okay, so when I add and subtract, the sign doesn't change. So plus 4, so -2 times x, -12. Now when I divide by a negative, the sign has to change. Okay, when you divide both sides by a negative, sign changes. So then you divide both sides by -2 x, and that's going to be 6. Okay, if you're dividing each side by a positive, sign stays the same, but if you divide by a negative, it has to switch. So x can be any number as long as it's less than 6. So 6 is the critical value. Circle it, but don't fill it, because 6 in itself is not an actual solution. So that is a less than sign now. It was greater than, but now it's less than. So x is any value less than 6. So that'd be like 5, 4, 3, 2, 1. That way. Please label your number line correctly. Okay, my next problem, 15f plus 9 is greater than 3 times the quantity 5f plus 3. So the first thing I need to do is apply the distributive properties. Since I'm not doing an operation on both sides, I keep the sign the same. Okay, so it's going to be 15f plus 9. Well, I need to solve for f. There's an f on each side. Not only is there an f on each side, the coefficients are the same, 15f, 15f. What that does is wipes the variables from the problem, and this becomes either an all solution or a no solution. So it says 9 is greater than 9. Well, if there was the equals to sign, it would be right because the 9s are equal, but there's no equal sign. So this is a no solution or undefined solution. No solution, undefined solution means the same thing. Okay. Next problem, -1 is less than or equal to x minus 3, and x minus 3 is less than or equal to 2. So we have a compound inequality. So with compound inequalities, I like to kind of make a chart here. So I have put each inequality in its own column. So this inequality, we have a -1 value on that side. On the other side, we have the expression x minus 3. Okay, so this side, we're going to have a 2, and then the expression x minus 3 repeats itself. So I solve these and graph them. So all I have to do is add 3. Well, that's not going to change our sign. Adding and subtracting on each side never does. So that's 2, and that's x. Now, I don't like it written that way. I would put the variable before the value, and then that would result in the sign changing to greater than or equal. Okay. Now here we'll add 3 to both sides. Sign will stay the same, and then x, and then 2 plus 3 is 5. So we have 2 and 5. Now you got to label these correctly and get the graphs right. Okay, so our critical values are 2 and 5. So both these would be filled in because we have equal to with both of them. Now that's greater than 2, so greater than 2 is this way. Less than 5. Less than 5 is this way. Now, a lot of you mislabeled this the other day. What you need to do is put x in the middle just one time. Put 2 on one side, 5 on the other. Now you have to fill in your inequalities. So you see how the sign, with x and 2, the sign eats the x. So between the x and the 2, it has to eat the x here, okay, with the equal to. It's eating the 5 there, so it will continue to eat the 5 here, okay. So if it's eating between x and 2, it's eating the x. It has to eat the x there, okay. That's how that has to be labeled, no other way. Okay, my next problem, we have 2x is less than or equal to -4, or 7x is greater than or equal to 49. So again, that's another compound inequality. So they're already separate for us. So we have 2x less than or equal to -4, and then 7x is greater than or equal to 49. So I need to divide each side by 2. So less than or equal, because it won't change because I'm dividing by +2. I don't care. It's a number I'm dividing by 2. So I have x is less than or equal to negative 2. Meanwhile, on the other side, okay, we have to divide by 7, so the sign will not change, okay? Divide each side by 7, and we have x. 49 divided by 7 is 7. Okay, so now we plot the solutions on a graph. So you have 0. Now you have negative 2 and positive 7. So you circle both of these. So that's a less than sign with the negative 2, so that'll be this way. That's a greater than sign with the 7, so greater than is this way. So now they go apart, okay? So complete the graph. Now, it's like the opposite of what's happening here. Now it's all numbers this way and this way. It's the extremes. So you write or, and when you write or, you just plot you just basically label what you have here. X less than or equal to negative 2, and then x greater than or equal to 7. Okay, now we're going to get into the new stuff. Okay, we're solving absolute value inequalities in this assignment here. Okay, so solve the inequality, graph your solution. Now, yesterday we solved absolute value equations, so what I would prefer you do is I would replace your absolute value, the entire thing, with d. D stands for distance. So we have a distance less than, that's less than 5. Okay, so we have our d value at 5, so I do what I did yesterday and just proceed to make the table. Now, a distance of 5 on a number line, well, that could be 5 less than or equal to 5 instead of just equals. But when you do negative 5, the sign needs to switch. Now, here's why that is. Okay, you don't need to write this down, just watch. So you have to flip it. Here's why. Okay, here's 0, here's 5, here's negative 5. A distance of less than 5 means you're going towards 0 from both directions. So when I go this way from the 5, I'm going in the less than. That's why that stays less than. But with a negative 5 to go in towards 0, you're actually going the greater than direction. So that is why that needs to switch. Now, inside the absolute value, you just have x. So this is pretty much solved for, but now we have to graph the solutions on a number line. So you put 0, you put 5, you put negative 5. You're going to circle. You're not going to fill in either circle because you're not equal. And that's a less than, okay, with the 5. So we go this way from the 5, and that's a greater than with the negative 5. So that would be this way. So they come together. When they come together, you put x, you put negative 5, and 5. Now let's talk about the 5. Well, it's eating the 5. It needs to eat the 5 here. Between negative 5 and x, it's eating the x. So it has to eat the x here. Okay, so that's how that needs to be labeled when they come together, and that's it. Okay, the absolute value of x is greater than or equal to 2. So again, remove the absolute value and put d for distance. So the distance greater than or equal to 2. Okay, so I have my d value of 2. So you put greater than or equal to 2, but then when you do the negative 2, you put less than or equal. Now, that's a greater than sign right there, and I'm going to illustrate why the sign flips. So we're talking 2 and negative 2. So the distance has to be greater than 2. That means it moves away from 0, so the distance grows. Well, with the 2, it's greater than, okay, that way is greater, which is I have down. But if I'm moving away from the 0, that moves away from the 0, so the distance between the negative 2 and the 0 is becoming greater, but we're going the less than direction, which is why the sign needs to change. Then you put your x down and you pretty much have it solved. You just need to now plot your number line. So you have 2, negative 2. So you fill in each one this time, okay? So you're greater than positive 2, and you're less than negative 2. So that's an or when they go apart. So on ors, you just put these labels on them, okay? So when they come together, you have to do this. Okay, and that's how you label. All right, next problem. It's a compound inequality. It will turn into such. Okay, next problem. Remove your absolute value from there, and you have d greater than or equal to 3. So I have my value of 3, so I'm going to put greater than or equal to 3, but then less than or equal to negative 3. And as far as why it flips, I just showed it right there. Now, bring in your absolute value expression of x plus 8. Now, you don't have this solved. You have to do some operating, okay? You need to minus 8. Well, the sign doesn't flip when you minus, okay? Because we have to watch for the sign switching since we're dealing with inequalities. So we have x, 3 minus 8 is negative 5. Okay, same thing here, sign's not going to change when I undo the one operation. So we have x, negative 11. So you have the solutions, now you just bring them to a number line. So they're both negative, that's okay. So you circle, you fill them both in. Okay, so that's greater than negative 5, but it's less than negative 11. That's an OR, okay? So you put OR between them, and you just simply put the labels on there, what you have up here. It's when they come together where you put the x in between them. Okay, we have the absolute value x minus 2 is less than or equal to 1. Okay, so d is less than, or the distance is less than or equal to 1. Okay, that's a very small range because you're at 1 and negative 1. Okay, so I have my d value at 1, less than or equal to 1, greater than or equal to negative 1, and inside you put x minus 2. Okay, so we need to add 2, which will not change our sign. So you have x and 3. Not change our sign. Negative 1 plus 1 is 2 is 1. Okay, so you have 0, so you have 3 and 1. So you're going to circle, you're going to fill in both the circles. So on the 3, that's less than 3, okay? So less than's this way, but greater than 1, so then it goes in between. Now you need to label that correctly. You put x, 1, 3, just like that, but now you need to put in inequality symbols. X in the 3, it eats the 3, it needs to eat the 3 here. X in 1, it eats the x, so it needs to eat the x here. Okay, it has to eat exactly what it's eating here. Eating means opens towards. Okay. Next one, the absolute value of 2x minus 5 is less than 9. So again, d is less than 9, so I have 9 as my d value, my distance value. So it's less than 9, greater than negative 9. So you have to flip when you do the negative. So, and then you put 2x minus 5. Now you need to solve. So you're going to add 5, which doesn't change the sign, and then you're going to divide by the 2, but you'll be dividing by a positive, so we won't change the sign there. So I add 5. 9 plus 5 is 14. Then I divide each side by 2. We have x, 14 divided by 2 is 7. Okay. Then here, okay, minus 5, add 5 doesn't change the sign, divide by 2 doesn't change the sign. If you're dividing by negative 2, it would, but we're not. Okay, so 2 times x, negative 9 plus 5 is negative 4, then divide by 2, and you have x, negative 2. Okay, graphing time. Again, yesterday we didn't have to graph because it was just equations. Okay, now they're inequalities. Anytime you solve an inequality, you need to graph it. Neither one's filled in. Less than 7, greater than negative 2. That is they're in between, so you write x, negative 2 on one side, 7 on the other. Eats the 7, and then it has to eat the x, but don't just copy the sign. Put the sign between the negative 2 and the x so it eats the x in relation to the negative 2. Just that's all you do. Okay, next one, the absolute value of 3x plus 1 is greater than 8. So this is kind of getting to be repetitive. Okay, d is greater than 8. So remember, greater than means the distance is moving further from the 0. Okay, so greater than 8, but then when you go negative 8 and move further from 0, you're going less than. And then inside you have the expression 3x plus 1. Okay, so I have to minus 1, which will not change the sign, and then I divide both sides by 3, which does not change the sign. So 3 times x, and then 7, then divide by 3. And then 7 divided by 3, yeah, decimal, that just never terminates. I don't want to see that, so you need to go, it's really easy. You click the second key, hit the PRB button, and click equals. Now you have an exact answer, 2 1/3. Okay, same thing here. You won't flip when you minus 1, but you will not, and you will not flip when you divide by 3. So negative 8 minus 1 is negative 9. Okay, all right, and those are your values. Neither circle's filled in. Okay, so that's greater than on 2 1/3, less than on negative 3, so we have an OR. So on the ORs, you just simply copy down what you got from the table. Okay, next one, the absolute value of 4x plus 1 is greater than 11, so we're going to have D greater than 11, so my D value is 11 units from 0. So greater than 11, but less than negative 11. So you bring in your 4x plus 1. So you'll need to subtract 1, which doesn't change the sign. You'll need to divide both sides by 4. So subtract 1 and 4 times x, and then 10. Then you divide by 4, and you have x and 2.5. Same thing here. Won't change when you minus 1. It's not going to change when you divide by positive 4. So 4 times x, negative 11 minus 1 is negative 12. Then you divide by 4, and you end up with negative 3. So your critical values, you plot those. You have 2.5, you have negative 3. So 2.5 you circle, negative 3 you circle, okay? Greater than, less than. So that's an OR. So x is greater than 2.5 or x is less than negative 3. Okay, now the next one, we have something going on here, okay? We're not going to have our D value right away. So you remove that absolute value and you're going to have negative 3D plus 4 is greater than negative 14. Now you're going to have to solve for the D now, okay? Solve for the variable D, find your D value. So you got times and plus. Now you have to watch for the sign switching. I'll minus 4 and it won't switch, but when I divide both sides by negative 3, it will switch. So negative 3 times D, and then that's negative 18. Now you're going to divide by negative 3, and you have D, and then 6. Okay, beautiful. So now I just continue. So less than 6, greater than negative 6. So now you bring in your x plus 2, okay, minus 2. So you have x, 6 minus 2 is 4. You're not flipping the sign because all you're doing is minusing. X, negative 8. Okay, so I plot positive 4, negative 8. Less than 4, but greater than negative 8. That's a betweener, so you put x, negative 8, 4. So if x and 4, it's eating the 4. X and negative 8, it's eating the x. So put the sign so it eats the x, just like that. Okay, now I want you to go to the single sheet. We're only going to do 2 of these. We're not going to do all these. We're just going to do this side. I'm going to do the one that says the ideal length of a nail is 20 millimeters. You can cross these back 2 out. Okay, these are examples. I forgot to put them in the packet. The ideal length of a certain length of a nail is 20 millimeters. The actual length must be within 0.4 millimeters of the desired size. Within means it can go, it's supposed to be 20, but it can go over by 0.4 or 4/10 of a millimeter or under by 0.4 or 4/10 of a millimeter. You need to write an inequality that describes the range of the acceptable lengths of the nail. Okay, so you need to find lengths, use lengths. Now to do a range, okay, you see we're finding the range, you're going to make a number line. Your job is to find the minimum and the maximum. Don't put 0 in the middle because you can't have a length of 0. Now this is very easy to do. You take what the length's supposed to be and you add and subtract the variation amount, which is the within value of 0.4. So first, 20 plus 0.4 is 20.4. Then I take 20 and minus 0.4. That's a plus minus I put, okay? 19.6. So you circle, they're both solutions because you can be equal. Then you just extend it, okay? Now I want that labeled. You're talking length. So you put your 19.6 and your 20.4. Now this is the maximum, so you eat that with the equals to, and then you want to eat the L, okay? You want to open the sign to the L. We shouldn't be opening the sign, the open part of the sign shouldn't go towards that because that's a lesser number. It always goes towards that, okay? And then you're done. You wrote it. Okay, and then this one, the ideal length of a horse fence is 300 feet. The length must be within, remember within means plus minus, within 5 feet of the ideal amount, okay? The ideal width is 450 feet. The width must be within 10 feet, plus or minus 10 feet of the ideal amount. Write inequalities for the range for both the length and the width. Now you got to do the length, and you got to do the width. I'll do the So your variation amounts are 5 and 10. So the length says the length's supposed to be 300, and you add and subtract the variation amount, which is 5. So you can go, if it's supposed to be 300, but it's okay if you go over by 5. So that's 305. It's okay if you go under by 5, and that's 295. But that's the highest acceptable, the lowest acceptable. So you fill those, and then use L as your variable, put 295 and 305. We got to have the sign opening towards the 305 because that's the highest, but we don't want it opening towards 295 because that's the lowest. Okay, it's the lowest possible value. Everything in the solution is greater than 295. Okay, now the width. The width is, read it, the width is supposed to be 450 within 10, okay? So your highest could be 460, your lowest would be 440, okay? It's really easy to do, actually. So width, 440, 460. Now write the inequality, less than or equal, and that's also going to be less than or equal. Okay, that's that applied to real life. Now your assignment's 6 problems, okay? Now, on number 6 on the assignment, you're doing a length width. Read the problem, okay? Do the length and the width. This 0.05 is what you use on both the length and the width to add and subtract. So you're going to use the same value, 0.05, okay? So when I do my length, I'm going to take 18.455 and add and subtract 0.05, and then 36.75 is supposed to be my width. I add and subtract 0.05.